Welcome to my walkthrough of the Nat 5 Applications of Maths 2026, Paper 2. This is the calculator paper. So we have the formula sheet. Again, we will reference this as we go through. Wherever it's relevant, I'll pull the information straight into the page that we're working on. In the exam itself, remember, if you get stuck, look at the formula list. It may just have the information you can't remember on it. So there are 7 questions on this one. I've not changed that page. That's fun. There's 7 questions. Question 1. A new housing development is being built in a village. The village currently has a population of 750. The developers expect the population to increase by 36% for each of the next 3 years. Calculate the expected population after 3 years and give your answer rounded to 2 significant figures. So we've got quite a few bits to this. We have our starting value of 750 people. We have a population increase of 36%, so that makes it 1.36 as our multiplier, and that's happening repeatedly for 3 years, so that's to a power of 3. We're going to work out what that is on our calculator, and then we're going to round to 2 significant figures. So let's bring up the calculator. Okay. We have got 750 times 1.636 to the power of 3. There we go. We've got 1886.592, 1886.592. Write down what your calculator shows, then do your rounding. Now, 2 significant figures. Remember, that means that we're looking for the first 2 numbers, and we need to take into account the number after it, but we are 4 digits from front to back from the decimal point. So we do need to make sure that we have 4 numbers there. So the 8 behind our point, our third figure, is going to turn that first 8 into a 9. So we have 1, 9. And to preserve our place, 0, 0. We don't need to put anything after a decimal point because it's irrelevant information. So that's the amount of people we are expecting. So I'm going to put predicted population. There we go. Question 2. Rachel's front door is in the shape of a rectangle with a semicircular window. The dimensions are shown. Everything is in meters. Rachel wants to paint the front of the door excluding the window. Calculate the area of the door to be painted. So we've got a rectangle and a semicircle. So the area of the rectangle is going to be 0.76 times 1.98, which is there we go, 1.5048 meters squared. Okay, and our semicircle, so area of a circle to begin with. If you look at your formula sheet, you'll see that the area of a circle is pi r squared. We're told that our diameter is 0.54, so our radius is going to be half of that, which is 0.27. So the area of the semicircle is half of the area of the full circle. So we're going to do 27 squared times pi, all divided by 2. And we get 1.145 and a bit. So 1.145. Hang on, I'm reading that wrong. 1,145.11 meters squared. I've done something wrong here. This doesn't make sense. I'm going to work this out. Okay, I know what I did wrong. That should be 0.27. Let's try that again. Well, and this is where they get you in the exam because you're in a rush to do things. You make mistakes. But it's recognizing that that was impossible. I mean, I'm just going to find that my decimal point moves with this. But I'm going to do it anyway. Divided by 2 equals, and it's 0.114511 and blah de blah. Right, okay. So our final answer, the area of the door to be painted, area of the door is going to be our rectangle minus our semicircle. So 1.5048 minus 0.114511. I don't need to go into that much detail, to be fair. So I have got 1.5048 minus 0.114511. It's going to get us 1.390289. 0.390289. Now I'm going to round that. That is meters squared, but I'm going to round that to something practical. So centimeter. So 1.39 meters squared to 2 decimal places. Okay. Question 3. Lee earns a gross annual salary of £42,000. National insurance is calculated on a person's pay before deductions such as pension contributions. Calculate Lee's annual national insurance payment. So we have £42,000. We're going to start with 42,000 minus the 12,584 that isn't charged anything. You can do it by hand, but I've got a calculator, so why do it by hand? 29416. Okay. Now he doesn't earn the above the next threshold, so we can ignore this last one completely. Every part of this 29,416 is at 8%. 8% of that. 8% is 0.08. So I'm going to times that by 0.08 and I get that's a lot of tax. 2353.28. 2353.28. 53.28. So his national insurance payment is £2,353.28. He pays 11.2% of his gross, so that's the 42,000, into the pension. Their annual income is 4787.12, and we have to work out the annual net pay. So let's work out their pension first. So we want 11.2%. So we're going to do the 42,000 times 0.112. That's a terrible zero. 42,000 times 0.112 is 4704. And their annual income tax is 478712. So we're going to do our 42000 minus our national insurance of 2353.28 and our pension of 4704 and our income tax of 4787.12. And that will give us the net pay. Let's have a look. 4200 minus 2353.28 minus 4704 minus 4787.12. So 30,155 and 60 pence. If you don't put that final zero, you will lose a mark, because money, when we talk about pounds, we talk about pounds and pence, and we do it to 2 decimal places. So that's the net pay. Okay. Next question. This question is basically a story following through for, I think there's 4 parts to this one. Shabazz is travelling from Glasgow to Barcelona, then Istanbul. Shabazz converted 840 into euros. He stayed in Barcelona for 4 days. He spent 205 euros each day that he was in Barcelona. He converted his remaining euros into Turkish lira. Calculate how many lira he received. So let's start off with converting £840 into euros. So I've got 840 times our conversion of 1.15 will get us our euros. I'm going to put the euro symbol in. We have 1.15 times our 840, 966. So we've got 966 euros. You can use the word euros or the sign for euros if you prefer. Some people prefer to put the euro sign before the numbers, some put it after the numbers. It's all good. He stayed in Barcelona for 4 days, so we've got 4 lots of the 205 euros he spent each day in Barcelona. So that is, again, you can work this out in your head, but 4 times 205, what's the point in risking making a silly mistake? 820, that's what he spent. So what's he got remaining? We're going to take away, so 966, take 820, 146 euros remaining. We need to convert the euros into lira. So euros to pounds, pounds to lira. So we're going to do the 146 divided by 1.15, and then we're going to times that by the 44. Now you can do it step by step. There's not a problem there. I'm going to do it all in one because I can. And I know this is going to get me a big number. Divided by the 1.15. So you can see there you'd have got £126, which is about what we would expect for the pounds. Times that by the 44, and we get 5,586 And lira doesn't generally have decimals, so we're not going to write down the decimals because there's a zero after the decimal point. So there we go. Okay. If you're not sure if a country has decimals or not, write it down with the decimals, usually to two decimal places. UK money, when I was a child, I am that old, used to have three decimal places because we had halfpennies. We don't have them anymore. But most countries that do use decimalisation do it to two places. Right, Shabazz flies from Glasgow to Barcelona. The plane departs at 1:30 p.m. local time. Barcelona is 1 hour ahead of Glasgow. So right away, I'm going to change that 1:30 p.m. to 2:30 p.m. Barcelona because we know that this is going to involve conversion. The plane flew 1,680 kilometres at an average speed of 600 kilometres per hour. So 600 kilometres per hour. How many hours did it take? So we're going to do our 1,680 divided by our 600, and that'll tell us how many hours we've got. If you're not sure, it's your distance, speed, time triangle. So I've got 1,680 divided by 600 is 2.8 hours. Now remember, you don't get, that's not 2 hours 80 minutes, that's 2.8 of an hour. So it's just over 2 and 3/4 hours. Calculate the local time the plane landed in Barcelona. So we are going to need to work that out exactly. So now we know we've got 2 hours. So we're going to do our 60 minutes. We're going to split it up. So we're going to divide by 100 and times by 80. We get 48. So it's 2 hours and 48 minutes. If you've forgotten how to do that, go back and look at the distance, speed, time triangle information and go back and look at time and conversion from decimal time to actual time in hours and minutes. Right, so 2 hours and 48 minutes after 2:30 p.m. So we have got, let's start with just adding on the 2. We get 4:30, and then we're going to add on the 48. Well, we can add that as a 30 and an 18. So that gets us to 5:18 p.m. There we go. It's up to you how you show you're working, or if you show you're working at that point. I like to work through separately for my hours and my minutes, so I'm less likely to make a mistake. Okay, question C this time. Now, I am not going to be able to draw this accurately because you have to do a scale drawing and I do not have the tools. So I'm going to make a rough drawing and mark it as if it was a scale drawing. So that means that the next bit I am not going to be able to do accurately. You guys are going to do this properly with a ruler and a protractor. I have neither. Right. I don't think there's any tools anyway. There was talk of an update, but no, we've not got any maths tools for that yet. Let's have a look. No, which is a shame. It's one of the things that is missing from these. Right, okay, let's work out our information first then. So the distance from Glasgow to Barcelona is 1680 kilometres, and we're doing 300 kilometres is 1 centimetre. So 1680 divided by 300 is how far? 5.6 centimetres, and that's a bearing of 161 degrees. And a distance of 2250 kilometres from Barcelona to Istanbul, we're going to do the same. 2250 divided by our 300 is how far? 2250 divided by 300 is 7.5 centimetres. Okay, I've managed to find a protractor that I can use, but I don't have a ruler that wouldn't scale as I use it. So we are going to start by marking our 161 degrees. Now I can't do it accurately because I can't see it accurately. So we are going to assume that 160 is, so 161 is here. And I'm going to have to, don't think this is going to stay. Oh, it did. That's okay. So that's the direction we're going. And we're going to go for 5.6 centimetres. I don't think I've even got enough room on here for that distance. Let me find the lines. And I need a thin line. Let's get this thin. And I'm going from Glasgow in that direction for what will be 5.6 centimetres, which I don't know how I'm going to do this. What you can't see is I've got a ruler on my drawing pad. I just can't get it low enough. No, I'm going to have to estimate that. Right, okay. And then I need another north line. So let me get another line. This one at least I can lock into north. And I want that to have an arrow on the top. Nope, I want an arrow on the top. Yeah, put a circle on the bottom for the sake of it. Okay. Right. Okay. So I have got in this bit that is 161 degrees, and my distance is 1680 kilometers, which is 5.6 centimeters. Now, in the exam, if you were having to do what I do because you've not got a ruler, you've got a straight edge on the edge of your protractor, marking your points in will mean you only lose 1 point for lack of accuracy rather than losing all the points. So as long as you write down what the distance should have been, you're showing you understood it. You just didn't have the tools to do it. You, however, will have a ruler on the day because you'll put your hand up and you'll ask the invigilator to give you one. Right. Now, oops, I need to go back to the selection tool. We now need to do our second part, which is 0.82. This is going to be interesting. Line back up with our protractor. I can see I'm looking at about here. And that's the direction I'm going to go this time. Oops, I still need my line. I need to make it a bit thinner. Right, so I'm starting down here and I'm going in that direction for 7.5 centimeters, which is going to be a little longer. Say that it's there. Okay. So, a few notes to make on this bit so far. I have got north here. I have got my degrees here for my bearing of 0.82. Remember, bearings are always given as 3 digits. And I've got my distance here of 2250 kilometers, and that was 7.5 centimeters. This is Barcelona. Istanbul's at the end. Now, because I know what these are like, I am going to draw another north line on the end. And then because I know I'm going to need it on the next page, I am going to screen clip this. I'm going to write my Istanbul here. Okay, that's us drawn our scale drawing. No matter how bad your scale drawing is, I went 2 pages. No matter how bad your scale drawing is, you can make it work. You really can, trust me. You will then need to determine the distance and the bearing of Glasgow from Istanbul. So you're going to do from the end back. There's my original. So what I'm looking for with this one is the straight line. I'm going to make it a dotted line from Glasgow, from Istanbul, sorry, to Glasgow. So that's the one I'm wanting. Okay. And I need to work out the bearing for that. Remember, bearings are always taken from north, so I am going to have to go all the way around to get this bearing. Okay. I would rather do the trigonometry version, but never mind. Let me steal this back. I want that protractor on the next page. Okay, so I know I've got 180 that takes me straight down. So I need to go the other way. I am looking at what number? Looking at, I think I'm looking at a further 118. So I'm going to say I've got 180 plus 118. So let's have a look. I don't want to make mistakes again. So 180 plus 118, 298 degrees. I'm going to do my bearing as 298 degrees, and my distance, I have no clue. I mean, you need to measure it. I'm going to measure, but mine sort of guesstimates at the best of times here. I'm gonna randomly call it 11. I'm gonna call it 10.8 for the sake of I have no idea. So what they want is whatever your length is when you measure it, you're going to times it by your 300, and that'll get you your actual kilometers. So 3240 I'm putting. Now we know mine's is going to be wrong because I've not got a scale drawing here. I've got a rough drawing. You're going to do it properly and have a scale drawing. Right, next question. Alan works for a company that lays patios. His current hourly rate is £14 per hour. He has a contract for 35 hours per week, but regularly works extra hours. Alan has been offered two pay options. Option one, he earns time and a half for any extra hours. So time and a half is his hourly rate plus half as much again. So his rate for option one is going to be £21 an hour for his bonus extra hours. Receive a 10% increase in his hourly rate, and all hours worked will be paid at this rate. So we need to work out what that would be. So we want, so option one, we're told that he works 40 hours, so we're going to work out which one is best for him for 40 hours. It's going to be 35 hours at £14 and 5 hours at £21. So let's have a look at that. 35 times 14 is 490. And I don't really need a calculator for this, but I'm going to do it anyway. We've got 105 for the second. So we have got what did I do there? We've got 490 plus 105 is 595. So okay. Option two is a 10% increase in his hourly rate. So we're starting off with our 14 times 1.1, 1.10 if you want. And then we're going to times that by all 40 hours. So our 14 times our 1.1, that's us finding 10%, so an increase, so plus 10%. And then we're going to times that. So the new rate of pay is £15.40 an hour. I'm going to write that up here just for the sake of having it. And we're going to times that by our 40. So £616. So option two pays more. There we go. So he gets a higher gross pay. Now we're going to see Alan doing some work. Alan needs to buy 120 paving slabs for a patio. He's comparing prices from 3 different shops, each with its own pricing. shop A, B, and C, and we're to determine the cheapest option. So we need to work out all three. So let's start with shop A. We've got £10 per slab, and there's a buy two, get one free. So we're getting three for the price of two. So we need to find out what 2/3 of 120 is. Again, this is an easy number. You would be able to do it by hand. There we go. And there's a good chance you'll have just seen that answer. So that's how many slabs he's going to buy, and they're £10 each, because he's going to get the third ones free for every bit. So times 10, we get our 800 with option A. Shop B got £9 per slab and a discount of 15% on the total. So we've got 9 times our 120. 1080. We're going to take away 15%. So we've got 100, take away 15 is what? 85. So he's paying for 85% of them. So I'm going to do 1080 times 0.85. 1080 times 0.85, and that's 918. If your calculator has a percentage button that you are comfortable working with, you could just put in 9 times 120 and then minus 15% equals, and you get your answer. If you're using a Casio, don't try and use the percentage button. It's safer to do the mathematical method than doing it using the percentage button. I don't know why the algorithm within the calculator messes up as often as it does, but it's not reliable for the percentage questions. Right, shop C. A straight up £7.50 for every slab. So 7.50 times 120 is £7.50 times 120, 900. So shop A is cheapest. Because of their nice little deal that they've got going on. Okay, next question. It takes 4 workers 15 hours to lay a patio. The patio company are able to provide 2 extra workers. All workers work at the same rate. Calculate how long it will take to lay the patio. Now, some of us can look at this and we get straight to an answer. There's a couple of different ways to work this. You can work out how long it would take if one worker did it. You can work out how long it would take if 2 workers did it, and you can work on fractions, you can work on ratios. I'm just gonna go with the flow and come up with one. So if 4 workers get us 15 hours, then 2 workers are going to need 30 hours. So 1 worker would need 60 hours. So we know that the job is worth 60 hours. So 6 workers they are going to take a tenth of that, so it's going to be 10 hours. Okay. So in total, 10 hours. The patio company completed the job for a customer. It cost the company £2,300 for materials and £672 for wages to complete the job. The customer paid £3,800 for the job. Calculate the company's percentage profit. Well, first of all, let's work out what the company I had to pay out in the first place. So 2300 plus 672. I don't like the wording on this question. 2972. All right, the customer paid 3,800, so 3,800 minus the 2,972, so we can find out what the actual profit is. So 3,800 minus 2,972 is 828, and that's the actual profit, and that was the actual cost. Calculate the company's percentage profit. Now, my neurodivergent brain is reading that and saying, okay, so what are we running the profit against here? What the customer paid? What the cost was to the company? I believe what the Qualification Scotland were trying to ask was the profit to be compared with the cost the customer paid, but I'm not sure, and that's why I hate the wording on some of these questions. So that's what I'm going to work it out as. What is the percentage profit of 828 compared with the 3,800? Okay, I just paused the video and asked for some clarification. Now, this is not saying that this is what the actual SQA is looking for, but I've been assured that at NAT 5 level, when they ask for percentage profit, they are usually meaning the percentage profit markup. So that would be the price, the cost price for the company. Now, if you're doing financial business work, and I also teach business studies, and I have done some accountancy courses, and then you'd be using the price the customer paid instead of the price the cost was to the company. So what we're going to do is both. So if we are looking at the let's see, the profit markup price, mark up, not it, then we're looking at the profit over the cost times 100%, times 100 to make 100%. So that would be 828 over our 2972 and then times 100, and that would get us in our calculator 828 divided by 2972 and times 100, 27.86 approximately. So 27.86% to 2 decimal places. Now, because I'm not 100% sure, because I would read it as the profit on the selling price, so out of every pound the customer gave us, how much did we keep as profit? So this would be profit margin. That's the profit over the customer's price. So that would be our 828 over the 3800, which is where my instincts were sending me. So 828 divided by 3800, and we're going to times that by 100, and we get 21.789. So that 9 makes the 8 into a 9, so 21.79. to 2 decimal places. Like I say, I'm not sure which one it would be, and quite frankly, I don't think it's worth the stress for the 2 points of working out which one it would be. I would just get the 1 point that you get for working out the 828 profit. Right. Katie's conducting quality control for a garden centre. We have bags of fertilizer. I have a story here. I'm not going to tell it today. Right, bags of fertilizer. We need 25 kilos plus or minus 4.8%. So 25 plus 4.8%. This calculator is not going to do that. I'm going to have to do right, let's work it out. So our max is going to be 25 plus 4.8%, which in a calculator is going to be 25 times 1.048. And our minimum is going to be 25 minus our 4.8%, which is, what is going to be 100 minus 4.8 is going to be 95.2. So our 25 times 0.952. Let's see what we get for our two numbers. So we get 25 times 1.048 is 26.2 is our maximum. And our minimum, it's not liking that. There we go. 25 times 0.952 is 23.8. Okay. So which ones are not suitable? So what is bigger than 26.2? That's bigger. That's bigger. Right, so we've got 29.9, we've got 26.5. What's smaller than 23.8? That's smaller. That's smaller. That's us. So 23.7 and 20.1. And that's us found our maximum, our minimum, and the bags that are not suitable. All 3 points. The garden centre recorded how many products it sells. A sample of the number of spades sold per month is shown. Calculate the mean and the standard deviation of the number of spades sold per month. So with mean, we don't need to put it in number order. You can if you want, but you're just wasting your time. You don't need it. So I prefer the x minus x bar all squared method. It is up to you which of the two standard deviations you're using. I am going to do an x column, an x minus x bar column, an x minus x bar all squared column. I've got 35, I've got 18, 28, 30, 32, 40, and 20. And I'm going to have my sum column down here. Let's see what we have. Right, we have got 35 plus 18 plus 28 plus 30 plus 32 plus 40 plus 20. We've got 203. Right, and we've got 1, 2, 3, 4, 5, 6, 7. So we're going to divide by 7 to get our x bar, which is our mean. So 203 divided by 7 gets us 29. All right. 35 minus 29 is 6. 18 minus 29 is minus 11. 28 minus 29 is minus 1. 30 minus 29 is plus 1. 32 minus 29 is plus 3. 40 minus 29 is plus 11. And 20 minus 29 is minus 9. Now we need to check that these all cancel. So let's just do it from top to bottom. So I've got 6, take 11, take 1, add 1, add 3, add 11, take 9, 0. There we go. That's what we needed, was that equals 0. We are good to go. Let's square everything. 6 squared is 36. Minus 11 squared is 121. Minus 1 squared is 1. 1 squared is 1. 3 squared is 9. 11 squared is 121. And 9 squared is 81. Let's add them all up. Perhaps I can use the one I wanted to use. Right. 36 plus 121 plus 1 plus 1 plus 9 plus 121 plus 81. 370. Okay. Now I did say that we might need the formula sheet for some of these. This is one of those. So let's jump to the formula sheet and our standard deviation. I'll just clip that out for us. And then we shall go back to our page 16. Oh, too far. There we go. And I'll just plop that back in there. Okay. So I prefer using the top one. If you prefer using the bottom one, that's up to you, whichever one you're more comfortable with. But this 370 is the sum of all my x minus x bar squared. So it is the top row of my standard deviation formula. So I've got my, I'm never going to get out of the habit of putting SD. My SD is the square root of 370 over n minus 1. Now I've got 1, 2, 3, 4, 5, 6, 7. 7 minus 1 is 6. So I've got the calculator for this. I want to do, because I know I'm going to need it, 370, open a bracket, 370 divided by 6, close the bracket, and I want to square root that. And I've got 7.8528, what, yeah, that. So 7.85, yeah, I'm just going to call it 2 decimal places. 7.85 to 2 decimal places. So I've got a mean of 29 and a standard deviation of 7.85. We're going to need that. We always need that. So 29 and 7.85. Mean of 29 and a standard deviation of 7.85. Right, so that was spades. And we're now looking at hoses. In the same months, the mean number of hose pipes sold each month was 18 and standard deviation was 13. Make 2 valid comments comparing the number of spades sold and the number of hose pipes sold. So we have 2 sentences. Try that again so you can see it. Right. So the number of spades sold and the number of hose pipes sold. 2 valid comments, one comparing the means Remember, we don't use the word mean, we use on average. So, on average, there were more spades sold than hose pipes. Like you could say, there were less hose pipes sold than spades. And for my next line, the standard deviation is 13. The standard deviation for spades was 7.85. Remember, the smaller the standard deviation, the more consistent the results. So the sale of spades was more consistent than hosepipes. There we go. We have got our two sentences. You could talk about the hosepipes being more varied, more spread. It's a good job we're not getting marked on our English skills because I'm having a not so great spelling day. There we go. Two sentences. That's all they need from us. One comparing the averages, one comparing the consistency. Right. Margaret buys a greenhouse from the garden centre. The advertised price was £900. She used a payment plan to purchase a greenhouse. The total price of the payment plan was 18% more than the advertised price. Before I get anywhere else, I'm going to work out what that is. So we need to do our 900 and times it by 1.18 to find out what she paid or what she's expected to pay. 900 times 1.18 is 1062. Okay, a fifth of the total price. This is our total price. A fifth of that is the deposit. Well, we know how to find a fifth. That's really easy. We just divide by 5. So our deposit is £212.40. Was what that said, wasn't it? Yeah. 10 equal monthly installments and a final payment of 160. Let's get that final payment out of there and then we can work out what the installments are. So we have got our 1062 minus our deposit, and then we're going to minus the 160. So we've got 1062 minus our 21240 minus the 160 final payment is 689.60. 689.60. If you're not following George the Mouse on YouTube, you're missing out. Right, and we want 10 equal monthly installments. So we're going to divide that by 10 to get us 68.96 per month. There we go. It's just being careful because the 10 equal monthly installments is what we're looking for, and that's in the middle of the things. You have to be careful that you remember to do all the bits, which is why you need to read through the questions carefully. Okie doke. Oh, I did jump there, didn't I? Here we go. A golf club has adult, senior, and junior members, ratio of 4 to 3 to 1, respectively. So that is adult to senior to junior. And we've got 4 to 3 to 1. We're told there's 102 senior members, so we know that that is 102. So let's find out what our scale factor is there. So we want 102 divided by 3. That tells it, I don't know what I did there. 102 divided by 3 is 34. So we've got a scale factor of 34. So 1 times 34 is 34, and 4 times 34 is 136. So there are all our bits. Now let's read the actual question. So we want to calculate the total number of members in the club. We know how many of each category we've got. So in total, I have got 136 plus 102 plus 34, which is 272. There are other methods of working it out. You could recognize that you have got 8 types. So you've got 8 things, and that 102 is 3 of them. So you'd still find that 34, but then you'd times it by 8 and you'd get your total number that way. I just think this is a more visual way, and then I was open for anything else they might ask me. Right. Okay. The club holds an annual ladies' championship. The winner receives a trophy, and the trophy has a metal top consisting of a cone and a sphere. The cone and sphere both have a radius of 3.5, so that's going to be 3.5, and that's going to be 3.5. Oh, and that's going to be 3.5, and that's going to be 3.5. So the height there is going to be 7, which means this bottom bit is going to be 4. I'm doing this because I have done these too often, and that's the one where they usually trip me up. So I'm parking on what I know. The total height from the top to the bottom is 11. And we're to calculate the volume in the trophy top, and this whole thing is called the trophy top. Right, so we need the cone and a sphere. We need their formulas for both. So let's skip back and get the cone and the sphere. Cone and a sphere is there. Okay, and we were way down here. This is the one we're on. Okay. Oh, there we go. Let's get that out our way. So we need to work out both. We know our radius is 3.5, and we know our heights. So volume of a cone, because I can, is 1/3 pi 3.5 squared times the height of the cone is 4, and volume of the sphere is 4/3 pi, and it's 3.5 cubed, and that gives us the total volume is the combined of both. Let's work out our numbers. We have got 3.5 squared, and we're going to times that by 4, times it by pi, and then divide by 3 is 51.31. I feel like I double clicked there. It's 51.31. Let's just check my rounding on that. Yep. And my sphere is cubed, and we're going to times that by pi, times it by 4, and divide it by 3. So 179.594. I might have done that twice actually, you know what? I'm going to try that first one again because I don't think I got that right. 3.5 squared. Did I just hit square root? No, 3.5 squared. No, it just looks weird. Right, times 4 times, I'm just doing 3.14 this time, and divide by 3. Oh, okay. So you can see the slight discrepancy between using 3.14 and using the pi button. They're not gonna check to a level where it's consistent with each other. So it would round to 51.3. Let's have a look at the other one then. Right. So I've got 3.5 cubed. Right, I've got times 4 times pi divided by 3, enter. There we go. 179.594. So 179.59. And this is centimeters squared, cubed, sorry. And this is centimeters cubed. I'm writing that there so I don't forget to write it on my answer. My combined answer, because I rounded, I've got 179.59 plus 51.31 is 230.9 centimeters cubed. Okay, so let's just be a bit careful. You saw that when I double pressed, I got this sphere volume came out really weird. So yeah, it's always worth double checking if you're not sure if you hit the right buttons on your calculator. 7C, we are nearly finished. There are only 7 questions, but 7 has quite a few bits to it. Right, the length of a golf hole is the distance between the tee and the flag. So that's the 430 meters here. And we're told that Laura stands at the tee and hits her ball. It stops 274 meters from the tee as shown in the diagrams. We're also given this 270 meters here, which is not mentioned in the wording. The distance between Laura's ball and the flag is the dashed line. Calculate that distance. Do not use a scale drawing. Yeah, because you've got enough paper and ruler for a scale drawing. Don't do it. Right, so we've got right angle triangles. Let's use them. So we know we've got a triangle that is 270 and 274 and h, and we can work out h squared as 274 squared plus 270 squared, which is 274 squared, 75076, 76 plus our 270 squared, 72900, which gives us a value of plus 75076. So 147976, 147976. Okay, we don't need to find the square root of that because we don't actually need the value of that height that I've put in. We're going to use the square, but we don't need the actual individual height. So we are going to use that in our next one. Why did I do that as a plus? It's a minus, isn't it? Okay. This is where you've got to be careful what you do. I'm looking at it, I'm thinking that How can that side be bigger than the start? Okay. Um, oops. What were my numbers again? 75076. 7 squared, 72900 minus 72900. Okay. So remember, because I'm not looking for the hypotenuse, it needs to be a subtraction. 75076 minus 72900, 2176. That's the same h there, so I don't need to change that number. But I do need to know this distance at the bottom of the bottom of this one. So I'm going to be 430 minus 270, which is what? 430 minus 270 is 160. So I have got 160 squared that I need to find. So that's 25600. Right, so if that is 160, and I need to find my unknown x, my x squared is going to be, this time it's not the it's the hypotenuse I'm looking for, so this time I add. So I've got my 2176 plus my 25600. So plus my 2176 is 2776. 776. So that is not my final answer. I need to square root it. And I can square root it and get 166.66. And that is in meters. There we go. Oh, you saw how easy it was for me to get caught out there. This is why, if you've got time at the end, you should go back and reread the questions. Just double check that you didn't get caught out the same way. Right. The golf club. The club shop sells boxes of golf balls with dimensions as shown. The boxes are shipped in a container with internal dimensions as shown. The boxes must be aligned in the same direction. And we're told this way up as well, so we know our maximum for our height won't be changing. Calculate the maximum number of golf balls that can fit in the container. So let's work out the height first. So for a height of 40, we're going to have 40 divided by our 4.3, and we'll see how many we can fit in that way. 40 divided by our 4.3 is 9.30. 9.3. So that is therefore 9 high, because you don't get 0.3 of a box. And now we've got two ways we can do this. We can do length and breadth, and length and breadth that way. So we can do 65 divided by the 17.2 and 52 divided by the 12.9. So 65 divided by 17.2 is 3.7, 3.8 to one place. and our 52.9, start that again. Our 52 divided by 12.9, that is 4, which is 4. Right, so a flat base altogether in the orientation we're seeing them in the image is 9 times 3 times 4 is 108. Right, okay, so turning it the other way and doing the 52 divided by the 17.2 and the 65 divided by the 12.9. Let's see what we get in that direction. So they're still facing the same way up, they're just turned around sideways in the box. So 52 divided by our 17.2 is 3, and our 65 divided by our 12.9, that's 5. Times by that 9 as well. So we've got 9 times 3 times 5, which is 135. So the maximum golf ball boxes is 135. Okay, and that is the last question. We are done. Hopefully you found this useful. I'm going to try and do these every year when the exams come out. I don't know if I'm going to be teaching any classes this next year, but if you want to reach out for me for tutoring or just general random questions that you've got stuck on, I'm always willing to send resources and video files and help out where I can. So good luck with your revision for the exam that you're looking for.